See Lindelof videos simplifying exponents, and here's a problem that really seems to throw people off. First off, whoever wrote this problem has this implied multiplication. This is all implied multiplication, so the reason that they put this here is honestly beyond me. But what I'm going to do is I'm just going to rearrange these pieces in the numerator for my convenience, and my argument for why I'm allowed to do that is called the commutative property of multiplication. And there are 6 different ways that you can multiply these 3 numbers together, and all 6 of those ways give you an answer of 24. So if you do 2 times 3 times 4, you get 24. 4 times 3 times 2, 24. 3 times 2 times 4, 24. 3 times 4 times 2, 24, etc. ad nauseum. So we know that we're allowed to move these pieces around. So I'm just going to move them. And because I want you to remember that this is not an event. This is kind of a process. So take your time to do this. This is worth doing correctly. So this x cubed is this one right here. And then I'm going to take this other x cubed right here. And then I'm going to take my y cubed, if you don't mind. And I'm not going to do anything with my 4x squared right here. I'm just going to leave it. And maybe you can see why I'm doing this, because if I multiply these 2 pieces together, I can't simplify this. This is x as a base of x, and this has a base of y. And we know to use the rules of exponents, the bases have to match. So we have x to the third times x to the third, which is x to the 3 plus 3, which is x to the 6th power, isn't it? So x to the 6th power. And x to the 6th power times y to the 3rd power is, well, x to the 6th power times y to the 3rd power. From here, I'm going to do this little bit of work here. I just want to show it to you one time the way I see this. If you don't mind, I'm going to rewrite my 4x squared. I'm going to write 4x squared here, because this is what I look at when I'm doing this problem. I look at it like this. I look at this as one problem right here. I look at this as a separate problem right here. And lastly, I look at this problem over here. The one thing I'm going to do to help myself is I'm going to put a 1 here, because that's 1/4, isn't it? So there's my 1/4. And 1 over 4 is 1/4. So I'm just going to do these. It's called partitioning. I'm going to do these things one part at a time. So 1 over 4 is 1 over 4. And x to the, so now I'm moving on to my second problem in orange here. So I have x to the 6th divided by x squared, which is x to the 6th minus 2, which is x to the 4th, isn't it? So we have x to the 4th here. Just so I can see this better, it's called rationalizing. I'm going to put it like this, right? Any number over 1 is the same number, isn't it? And then if you don't mind, the last thing I'm going to do is that this y cubed is the same as y cubed over 1. There's nothing I can do to simplify this, so I'll just write it again, y cubed over 1. Now, just to finish my answer, I am going to go ahead and simplify this. And 1 times x to the 4th is x to the 4th. X to the 4th times y cubed is x to the 4th y cubed. And here's the tricky part. 4 times 1 is 4, times 1 again is 4, and there's our simplified solution. What am I trying to tell you here? What do I think is helpful? What I think is helpful is when you have a problem that's like this, take your time and look at this piece by piece. Math is really worth doing well, and I know that sometimes we have teachers who are in a big hurry or tell us this is easy or whatever crap it is they're saying. I'm telling you, take your time. You can figure this out. Do some examples and figure out not just how to do this, but why does it work. So let's do this second example right here, if you don't mind. This one, I'm just going to rewrite it again. I don't always rewrite them, but this one just needs to be rewritten, I think. So this x right here is this x right here. This solidus or division bar right here is this one right here. And then I'm going to look at the denominator a little bit differently. I see the 2 there, but I also see this. I see x to the 0 power. And we know that x to the 0 power is equal to what? It's equal to 1. So as long as x is not equal to 0, and that's a caveat that we have to think about. So automatically I can just cancel this out and make this 1. And 2 times 1 is 2, so there's our 2. And now what we have to do here is this. What rule is this? This is 2 to the 2nd power, and 2 to the 2nd power is 4. So there's our easy answer there. Look, you guys, I hope this is helpful. People ask me, what will I ever be able to do calculus? Will I ever be able to do Calc 2 and Calc 3? The answer to that question is a simple one. If you find a way to learn how to do algebra well, you can definitely do very, very difficult math. But without us figuring out a way to do algebra and algebra 2, it is almost impossible to be any good at calculus at all. So if I can be helpful in any way, let me know. Your comments are always welcome, and if you haven't already subscribed, please do. Thanks. Peace.